Welcome back. Today we're going to talk a little bit more about solving log and exponential equations. So you remember last time we talked about this method of rewriting the equation, either taking it from exponential form and turning it into log form, or going the other way. So let's review that real quick. So here's an example where we want to solve for x. We're told 10 to the x equals 50. And so what I'm going to do is I'm going to rewrite this in log form. So I'm going to take log base 10 of 50 equals x. Okay, so I'm basically just following this rule here that if you have something written like that, it's the same thing as that. And so I'm just rewriting it using logs. And what that does is it tells me that x equals log base 10 of 50. Now, you probably don't have memorized in your head what log base 10 of 50 is, but we can type that in a calculator and see what it comes out to be. I believe it's about 1.698 or something like that. I only have it memorized because we've talked about it so much in the last couple of days, but you can just grab a calculator and type it in. So for this problem, we want to kind of do the same thing, but you'll see that we're a little stuck because we have this divide 2 over on this side. So we're going to have to do something to fix this before I can apply my strategy of rewriting it as a log. And one maybe obvious thing to do is you can multiply both sides by 2, and that will cancel out this division going on over here that's messing things up, and you'll be left with 10 to the x equals, well, 40 times 2, that's 80. And then from there, I'm able to rewrite it using my logs. So I can say this is log base 10 of 80 equals x. And that I can just type in my calculator and figure out. I think that ends up being 1.903 or something like that. But the idea here, we're trying to get this 10 to the x by itself so that it's equal to a number, and then I'm able to rearrange stuff into my log format. Okay, so basically just doing things to get 10 to the x by itself. So here's another example we're going to try. It's got a little more going on here, but basically the strategy is the same. We're going to try and get this 5 to the x by itself so that I can use my logs to rewrite it. Okay, so what do I have to do to get 5 to the x by itself? Well, first I got to get rid of this subtract 20 that we're doing and this times 16 that we're doing. And remember, when you're undoing stuff, you have to do it in reverse order of your order of operations. Okay, so add and subtract is the last thing we do when we're calculating something. It's the first thing we need to undo when we're going backwards. So we're going to undo this subtract 20 by adding 20 to both sides. Okay, so that's going to undo that. And we'll get 16 times 5 to the x is equal to 60 plus 20 is 80. Okay, and now that I've done that, I can successfully get rid of this times 16 by dividing both sides by 16. So I'm just going to divide both sides by 16 here, and that will cancel out over here with the times 16, and we will get 5x by itself is equal to 80 divided by 16, which is 5. You can use a calculator if you want to calculate that, but I just happen to know that it's 5. And so now I'm able to write this in log form. Log base 5 of 5 is equal to x. Now log base 5 of 5, log of any base of the base. Now log base 5 of 5 is equal to 1, because how many times do you multiply by 5 to get 5? And do it one time, or 5 to the first power is 5. So x is going to equal 1. So again, our strategy here was to take this equation and just kind of get rid of stuff by using inverses until we were left with just a single exponent equals a number, which we can then rewrite as a log and calculate. Okay, this idea of preparing the equation like that works going the other way too. We can get the logs by itself and rewrite it as an exponent, and it'll work just as good. So in this equation, we want to get the log base 3 of x by itself. So I'm going to get rid of the add 7 and the times 2. So first I'm going to subtract 7 from both sides. And that will leave me with 2 times log base 3 of x. Sorry, my parentheses don't show up too good when I use my mouse. And that is going to equal 11 minus 7. That comes out to be 4. Okay, now the next step, I want to get rid of this times 2. So I'm going to divide both sides by 2. Okay, and that will cancel over here. The times 2 and the divide by 2. And 4 divided by 2 will come out to be just a 2. And so that will equal log base 3 of x. Okay, and now I can rewrite this as an exponent. So I can basically apply this rule going the other direction now and take something that looks like this on the right and make it look like this on the left. So let's go ahead and do that. So that'd be 3 squared equals x. And I know 3 squared is 9, so don't need a calculator for that. X comes out to equal 9.